same page. Number 30. This is my claim. If you did it, just check your answers with me. This is my level of significance. This is given to us. We'll do it here and we'll do it with the calculator. All right, let's work on this information. This is all they gave us. We're testing this claim. The claim is that the mean is less than or equal to 22,500. Is that the HO or the HA?
That's the
HO, good. What's my HA? Greater than. These are my steps that I need to solve. Lay out your claim. Remember that little list that we did yesterday to test this. We need to find our level of significance. We need to make sure it was approximated a normal curve. State your claim, your HA, your HO. We need it to sketch. What tail test is this? A right tail test. This area is your p-val. This is your z-score associated with that probability under the curve. Now, I know what I have. I know how to find my p-val. If I find my z-score, I know how to find my z-score. I just put it all together now. Find your z-score. I have a sample. So I find my z-score. I've got all my information. My x-bar, my mean, divided by my standard deviation, and n. And so anybody find me a z-score? Did you do this one, Felicia? You had this z-score?
Yeah, that's all I got.
Okay, so what'd you get for your z-score?
5.59.
5.59? Okay, now we need to find the area to the right. What is the area to the right of 5.59? Like 0. It's just absolutely like close to 0. Your table only goes up to 3.49. 5 is way, way out there. So virtually, my p-val is approximately 0. There is no area to the right. So, but what did the rest of it say? E to the negative 8. That means you move your decimal 8 places to the left. Now, I did my work. I test. P-val, level of significance. You see this test up here in the chart? Down there as well? I'm testing my p-val, which is 0, to basically my level of significance, which was 0.01. And obviously it's going to have to be less than, right? Less than or equal to. I follow my chart. What's my decision? Reject HO. Now, you rejected HO. When you go here, you don't like this one. You have to go with this one. But that was the claim. You rejected the claim. You're not liking the claim. But we can't say it's false. I don't like it. We have to follow your chart. So we follow your chart. Your claim is your HO. You rejected it. There is enough evidence to reject the claim. This is so important, guys. And all we know from this problem is the claim was the mean is less than or equal to 22,500 because they didn't give us a scenario at the level of significance of 0.01. This is the most important part. You challenge this, this is what you concluded. We don't like it, we don't want it, it's false, it doesn't work, we found that it wasn't good, but we can't say that. There's enough evidence to reject it.
You can just say like the 1%.
At the 1%, that's fine. At the 0.01, at the 1%. Everybody okay with this? Now, in your calculator, if you haven't tried it, try this. Here is your, go to stat, go to test. You're right at the top. Your z-score, if we approximate a normal curve or greater than or equal to 30, and our standard deviation is known, our population. So we're here. Just as you used this before, this is your mean, 22,500. your standard deviation, pull it right off your paper. Your X bar, 23,500. Your N, 45. Now your tail follows the HA. Here's my HA, it's pointing to the right. I want the tail that points to the right. Follows the HA. Calculate. There's my Z-score, 5.59. There's my p-val, but look, this is a scientific notation. Your p-val, could it possibly be greater than 1? Why not?
Because it's to the negative.
Nope, why not? Why can't your p-val be greater than 1?
Because the chart, the table doesn't go up to
Nope. At the calculator. P-val is what? Area under the curve. But why can't it be greater than 1? Why can't your p-val be greater than 1?
Because it's like one, it's the really defining like a percentage and it all goes into 100%.
Ah, that's it. You said that?
Yeah.
Oh, sorry. I took it as your Z-scores went up to 1. I'm sorry. You both hit it on the head here. If your area under the curve maximum is 100%, or Hilda said 1. So it can't possibly be greater than 1. But look what's out here. E to the negative 8. That's a scientific notation number. Move the decimal 8 places to the left. It's virtually 0. So all you have left to do is to test it. You bypass this piece right in here. You bypass this by using your calculator. And it helps you to do that. Find your Z-score. You can still find your critical regions when we go to do that part. You can still find your p-val. It gives you that right there. You don't have to look it up on your table. And we're good to go. Questions? Everybody understand this? All right, let's do 31. 31 is a nice word problem. And they worded it a little differently. Just like yesterday's problems were worded differently. But for you to understand this, after you read the problem, go look at what you're supporting or rejecting. That's your claim. So, 31 says, a random sample of 50 medical school applicants at a university has a mean score of 31 on the multiple portions of the MCAS. A student says that the mean raw score for the school's applicants is more than 30. You assume the population standard deviation is 2.5. Here's the key. At a level of significance, is there enough evidence to support the student's claim? I need to know if there's enough evidence to support the student's claim. Right away, the word support tells me which one is going to be my claim, HO or HA? HA. My student's claim, I go back to my information. My student's claim that the mean raw score was greater than 30.
HA.
HA.
Oh, wait, that's it.
I got to have my student's support. I got to have the claim be HA.
Oh, yeah.
What's the HO?
Plus the
Okay, now, they just happened to put the sample information first. That's all they did. Normally, in the other problems, they make the claim, and then they said someone does the sample of blah, 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 and finds da-da-da. They just put it first. It's okay that they put it first. Go to the bottom and see what they're looking for. So now, out of 50 students in my sample, they're still talking about my sample. The sample mean was 31, and they found the population standard deviation, assume that it was 2.5. Our level of significance is 0.01. We know everything else. Everything works the same. What tail test do I have?
You have the, right.
A right, because I'm going to follow the HA.
Oh, yeah.
Okay, so I need to find my p-val. I need to find my z-score, and then I can look up my p-val. So I do my z-score test, x bar, 31, minus the mean, doesn't it have to be positive? Over the standard deviation, divided by the square root of 50. I find my z-score, and I get a z-score? 2.83? Thank you. That's pretty far up there too. Now, here's the thing. When I look up 2.83, I get the area to the left. So I want to subtract it from 1. It's going to be like 0.89 something. It can't possibly be more than 50% of the curve. It's a little tiny section. Or on the flip side of it, I can look up the negative 2.83 because this area is symmetric to this area. So I don't care which one you look up, either one. So you look it up, and what p-val do we get?
You get 0.0023.
Okay, done. All we have to do now is test. P-val, level of significance. 0.0023 to my level of significance, fill it in, is 23 less than or greater than 100? Less than. So we know that this guy uses the less than or equal to, and if he didn't put the equal, it doesn't matter. So no, so it's going to be reject. Reject, HO. Now, when you come to the reject HO, you don't want that one. So therefore, HA, aren't you going to be able to support your claim?
Yeah, there's enough evidence to support the claim that at the 1% level of significance, the mean raw score for the school's applicants is more than 30.
Good.
Can I shorten this up?
Can't shorten it down too much. It's more than 30, right?
Yeah.
This is the most important part of your test, is what you conclude. No one sees all your Z-score tests. No one sees your calculator. They see your information. They don't see your chart, your tail test. They see your answer. There's enough evidence to support the student's claim that the mean raw score is more than 30 on the MCATs. At the level of significance of 0.01. Okay? Are we feeling a little bit better? It's messing me up with this stuff. Alright, is everybody able to test the p-val against the level of significance? And yes, all the less than's have an equal sign. You can make a decision based on your p-val. You can fill it with the zeros. Easiest way, fill it with zeros and take the decimal away when you test. If you fill this with zeros, this is saying 461 is greater than 100. 461 is less than 500. 461 is less than 1,000. Notice what happens. Once you fail the 05, you're going to definitely fail the 10, aren't you? Because it's a greater number, right? Then you're less than. And the same with those. The 10 and 12 just gave you the z-score. You had to find a p-val, area to the left, in whatever tail you're looking, in this case to the left, and then test it against your level of significance and make a decision. I need you to tell me if you're not getting this, because this is so important.
Well, for number 12,
Right tail test.
yeah. I got something else.
What'd you get?
I got that the level of significance was 1,000, but then the p-val was 0.8907.
But is that possible? If it's a right tail test, could that little space be more than 50%? So what does that mean you have to do to your p-val?
Oh, you had to
Subtract it from 1. Use your chart to help you. Or you could take the negative, because it's the same area as the side to the right, and look up the negative. But your p-val can't possibly be more than 50%. That means, it's got to subtract it from 1. Two-tail test? A two-tail test, look up your area to the left. Why look up the right, subtract it from 1, and then multiply it? Look up to the left, find your area, multiply it by 2. It gives you twice the chance in the two-tail test. Okay, and then we got to these guys. We did 27. No, we didn't do 27.
What was 14?
14. Two-tail test. Okay? Okay, 27. Rick, if you're having trouble with 27, your claim whoops, this is backwards. Your claim is your HO. Your tail, your HA is where your tails come from. You're not equal. Okay? So you're going to use that information to find your z-score. You're going to plug it in your z-score formula or plug it in your calculator. Find your z-score. This is a two-tail test. Your area under one tail and multiply it by 2. And then compare it. They didn't really give us a big scenario here, so we'll just say the claim value is equal to 40. Okay? We did 30. And we did 31. What I'll do is, did you guys finish 33 and 34? Alright, we'll hold it off here. I'll let you finish these.